Hi everyone. In this video, I'm going to do a trace of the bubble sort algorithm. My one sentence description for the bubble sort algorithm is perform pairwise comparisons and bubble large values to the end. As we do a trace of bubble sort, I'm going to tell you or show you when the bubbling is happening so you can see where bubble sort gets its name. So what I have here are 9 playing cards shuffled into a random order. And under the playing cards, I have 2 brackets. And the first one is this red one, which denotes what portion of our array or our list of cards is unsorted. So right now, since I haven't started the bubble sort algorithm, the entire list of cards is unsorted. And then at the end here, I have a little green bracket, which is currently not pointing to any cards, which is going to be the sorted portion of the array. So with bubble sort, we build the sorted portion of the array from right to left. Okay, because large values are bubbling to the end, the large values are going to end up in their sorted position first, which means each iteration of bubble sort, our unsorted portion of the array will shrink by 1, and our sorted portion of the array will grow by 1, building our sorted portion of the array from right to left. All right, let's go through it so you can see the algorithm in action and so you can see the bubbling. All right, so here's how bubble sort works. We start with the first element in the unsorted portion of the array. We perform pairwise comparisons, always swapping if the value on the left is greater than the value on the right. Okay, so 7, is it larger than 4? Yes, it is. So we're going to swap the 7 and the 4. Now, the 7 is a fairly large value, and it's going to bubble towards the end. So right there, we just saw a little bit of bubbling. So let's see if 7 bubbles again. Is 7 greater than 3? It is. So 7 bubbles one more spot over. But for this iteration, that's the end of 7's bubbling. Because now we perform the pairwise comparison between 10 and 7. Is 7 greater than 10? No, it's not. So we don't do a swap right here. Now 10 is our current element. Is 10 greater than 8? It is, so we swap. And since we know 10 is the largest value in this array, we're going to watch 10 bubble all the way to the end in its sorted position. 10 greater than 6? Yes, so we swap. 10 greater than 9? Yes, so we swap. 10 greater than 2? Yes, so we swap. 10 greater than 5? Yes, so we swap. We've reached the end of our array. 10 is the largest value in the array, so it bubbled to the end, and it's now in its sorted position. So our unsorted portion of the array shrinks by 1, and our sorted portion of the array grows by 1. So that was the first pass or the first iteration of bubble sort. Now we apply bubble sort again, but this time our problem is just a little bit smaller, right? Our unsorted portion of the array only has these 8 cards because we shrunk it by 1 with our first pass through with bubble sort. All right, so we know that 9 is now the largest value in our unsorted portion, so we expect 9 to bubble through and end up right here. Let's do the trace and let's see it happen. So remember, we're performing pairwise comparisons and always bubbling our larger values. So swapping if the value on the left is larger than the value on the right. We start with the first element in our unsorted portion, 4. Is 4 greater than 3? Yes, it is. So we swap. Is 4 greater than 7? No. Is 7 greater than 8? No. Is 8 greater than 6? Yes. So we swap. Is 8 greater than 9? No. Is 9 greater than 2? Yes. So we swap, and we watch 9 bubble to its spot. 9 greater than 5? Yes. 9 has now reached its position. Unsorted portion shrinks by 1, and the sorted portion grows by 1. All right, that was the second iteration of bubble sort. Now we go through again. We start with the first element in the unsorted portion. Is 3 greater than 4? No. Is 4 greater than 7? No. Is 7 greater than 6? Yes, so we swap. Is 7 greater than 8? No. Now we're going to watch 8 bubble to its sorted position. Is 8 greater than 2? Yes, so we swap. Is 8 greater than 5? Yes, so we swap. 8 has now ended up in its sorted position. Unsorted portion of the array shrinks by 1, and the sorted portion of the array grows by 1. So that was the third iteration or the third pass of bubble sort. All right, we start with the first element in the unsorted portion of the array. 3. 3 smaller than 4? No. 4 smaller than 6? No. 6 smaller than 7? No. 7 smaller than 2? Yes. So we swap. We're going to watch 7 bubble a little bit. 7 greater than 5? Yes. So we swap. 7 is now in its sorted position. So our unsorted portion of the array shrinks by 1, and our sorted portion grows by 1. All right, I'll go a little bit faster through the rest of bubble sort. Okay, so we're about to start the 5th iteration of bubble sort, right? This was the first iteration, this was the second iteration, this was the third iteration, and this was the 4th iteration. So this is the start of the 5th. 3 greater than 4? No. 4 greater than 6? No. 6 greater than 2? Yes. Swap. 6 greater than 5? Yes. Swap. Shrink by 1. Grow by 1. 3 greater than 4? No. 4 greater than 2? Yes. 4 greater than 5? No. 5 is in its sorted position. Shrink and grow. 3 greater than 2? Yes. So swap. 3 greater than 4? No. Shrink. Grow. 2 greater than 3? No. Shrink and grow. And in fact, I don't have to do any more comparisons because I know this has to be the smallest element, which means my array is now sorted and bubble sort is done. Now, I will mention there is a small improvement to bubble sort, which is called an early exit bubble sort. And if bubble sort on an iteration or a pass ever walks through and does pairwise comparisons and does not make a swap, like what happened on our last iteration here with the 2 and the 3, if it doesn't make a swap, then all of the elements are in sorted order in the unsorted portion of the array, and there's no need to continue on. So you'll often see bubble sort with that little improvement, which is if you don't make a swap on an iteration, then you're sorted, you're done, and then you have an early exit from the bubble sort algorithm. So I like to do these traces. On playing cards because a lot of people have playing cards laying around. So to practice, I highly encourage you to grab a deck of playing cards, grab numbers from one suit, shuffle them, lay them out in front of you, and go through and apply all the sorting algorithms on your deck of cards in order to practice. Because I strongly believe that if you understand the algorithms and you can trace through like this, then you can derive the code for the algorithm. You just got to start thinking about what are you keeping track of and how can you use loop control variables and data variables to keep track of things like what's your current element, what are you swapping with, etc. All right, thanks for watching.